Hey, geometry. Yeah, today's been crazy as well. I've spent the last probably 3 hours trying to get my videos onto Google Classroom for algebra. So I hope this one shows up. If not, you're just going to have to subscribe to my YouTube channel or check my YouTube channel daily to see the new videos. I'll label them with the date and geometry attached to it. So today will be March 25 Geometry in the title of the video. I hope this loads up to Google Classroom though. If not, I'll put out a blast so you can read it online. As a reminder, in today's lesson for the first semester review, external angles are on the outside of the triangle. They are 180 minus the internal angle. So this right here would be the internal angle for this external angle. External angles are all on the line, so they are 180 degrees. Also, the word non-collinear. If we're talking about a plane, we need 3 non-collinear points. That means that they're not lined up. Okay, so I'm going to kind of run through this assignment. This video may be a little bit long, but I'm going to kind of run through and say what my first thoughts are on each of the problems, and hopefully that helps you out. Once again, if you have specific questions, ask them in the comment section of Google Classroom. Don't ask them in the comment section on YouTube. I'm not checking that. I don't think any sane person does check the comments of YouTube. So, number one, name the intersection of planes A and B. Remember, the intersection of two planes, just like the intersection of these two boards, would be a line, right? So we're looking for the line where the two planes intersect. Number two, how many non-collinear points are needed to determine a plane? It's always a minimum of 3, right? Number 3, 5 points A, B, C, D, and E are collinear, not necessarily in that order. AB has a length of 24. Point C has a midpoint of AB and point D. Draw a picture. It's going to make this one a lot easier. Draw a picture before you even get started on that. Number 4, find 2 possible lengths for CD if C, D, and E are collinear. This one's draw a picture as well. It'll make a lot more sense. Number 5, the coordinates of, find the coordinates of a point Q. Q is not on there, obviously, if P is the midpoint of NQ. So you double the length from N to P, and you make a new point Q after P. What is the distance from R to Q shown in the figure? The shortest distance from a point to a straight line is intersecting at 90 degrees. So you need to find the slope of that line and do a perpendicular slope. How do we find the slope? Or how do we find the perpendicular slope? We take the original slope. Let's say it was originally 2/3. Take the original slope and we're going to flip it and change the sign. So our perpendicular slope would be 3/2, but negative 3/2. Okay. That's how we figure out what a perpendicular slope is. So you're going to go from R with that perpendicular slope of Q to run into that point, and you're looking for the shortest distance from that point to a line. Number 7, in the figure above, PC bisects BPD and BP bisects DPA. DPA is 146 degrees. What is the measure of CPD? DPA. So the whole thing is 146 degrees. You're looking to use the word bisect to split things into groups, okay? So now you can use algebra, a little bit of algebra, to find the missing data. Number 8, find the measurement of these angles if they're complementary, and 4 times. Okay, so you're going to use algebra again, but what does the word complementary mean? It means that those angles add up to 90 degrees, okay? So make sure you use that info when you're solving. Number 9, which pair of angles are supplementary? Well, supplementary, you need to know that supplementary angles are 180 degrees. And then 10, which are vertical angles. If you forgot what vertical angles are, we have 2 lines that intersect. The intersection makes 2 sets of vertical angles. The angles that are opposite of each other are vertical angles, okay? And number 11, if the measure of angle ABC equals 34, find the measure of CBD. So start with the picture, start labeling your angles and solve. Don't forget that box means 90 degrees. If ABC, number 12, if ABC is congruent to EFG, angle EFG, and the measure of angle ABC is equal to 41, find the measure of angle GFE. Use the term congruent. Use your definitions for that one. Number 13, determine whether statement 3 is a valid conclusion of statements 1 and 2. If all the sides of a quadrilateral are equal, then so check your definition of a rhombus and check your definition of a quadrilateral. You'll be able to figure that one out with ease. Number 14, all parallelograms are quadrilaterals. So all parallelograms are quadrilaterals. You have to write that in if-then form. Please use yesterday's notes to do converse, inverse, and contrapositive. It follows a little bit of formula. So just identify your hypothesis and identify your conclusion. Write it in different ways. Excuse me. In diagram AE is parallel to CD. The measure of angle EAB is 62, and the measure of angle BCD is 55. What is the measure of angle ABC? You remember whenever you have those intersecting points, you can extend a line to help you find the measure of those angles and find the missing things. So please make sure you do that. It will definitely help you out. Also, remember that the alternate interior angles are going to be identical, and that might also help you out. Number 16. So in other words, on number 15, in other words, extend AB out to help you find that angle, or extend CB out to help you find that angle. Number 16, based on these points, determine if CS and KP are parallel, perpendicular, or neither. Parallel, you're looking for the same slope. So if you forgot, the slope formula is y2 minus y1 over x2 minus x1. It doesn't matter which point you call 1 and 2, but it does matter which point you group together. So group C and S together, group K and P together. If their slope is parallel, or if their slopes are identical, then it is parallel. If their slopes are opposite reciprocals, meaning flip it and change the sign, they're perpendicular. If it's neither of those, then the answer is neither. Number 17, which of the following equations best represents the perpendicular bisector of AB? You're going to have to find an equation that goes perpendicular to AB, so you're looking for an opposite reciprocal slope. Find the coordinates of the point Q on AB, so the quarter distance from A to B. Number 18, if you're looking along with me, the wording is very important. From A to B. So we need point Q on AB that is a quarter distance from A. So you're starting at A, a quarter of the distance to the way B, toward the point B, sorry. So it should be significantly closer to A than B. Let's see, 19. Given P is parallel to Q and the measure of angle 3 is equal to 75, find the measure of angle 5. All right, that's just doing vertical angles and figuring out which one adds up. We have 360 degrees in this cross sections, 180 degrees for angle pairs. So we have supplementary angles going on. Let's see, P and Q are parallel, and we're looking for angle 3 and angle 5. So those are opposite interior angles. We have a special rule that belongs with that. Number 20, given angle 1 is congruent to angle 5, which postulate or theorem justifies that P is parallel to Q? Remember all your angles. We have alternate exterior, alternate interior, consecutive interior, and corresponding angles. Look back on your notes, or you can Google those definitions to kind of help you out with that. If angle 12 is congruent to angle 14, which postulate or theorem justifies that P is parallel to Q? For number 21, it's still those rules, those angle rules. Those are definitely in your notes. Those should be kind of memorized by now-ish. But recheck your notes or just Google those interior, alternate exterior angles, interior angles, and all that good stuff. If they're the same, they are parallel, right? If those interior angles are the same, then they are parallel. So if P is parallel to Q because consecutive angles, so number 22, if P is parallel to Q because consecutive interior angles are supplementary, then which angle pair must be supplementary? Kind of work through the diagram and figure out which one it has to be. You remember supplementary angles do not have to touch. You remember drawing supplementary angles like so, right? They don't have to touch. Okay. Moving on to 23. What is the measure of angle 2? So just fill out that form until you're able to identify it. Oh, no. New diagram. Measure of angle 2, measure of angle 1. We can use the triangle, and we know that triangles have to have interior measures of 180 degrees. We know that there are exterior angles outside of angle 1. It has to match up with exterior angles outside of the other one. So we're able to find out, and we can see that angle 1 is also a vertical angle. That means that they have to be congruent. That will help us define what angle 1 is, help us define what angle 2 is, and so on and so forth. Let's see. Same thing for number 26. Sorry, 24. Number 25. If triangle LMN is isosceles and T is the midpoint of LN, which postulate can be used to prove MLT is congruent to MNT? We know that middle line has to be congruent. We know that isosceles means we have the same sides. If it is the midpoint, that means it's halfway in between. We can definitely use side angle side on that one. Does angle prove anything? No. And remember, angle side also doesn't prove anything. And D says ABC. No. All right. If the measure of angle, if triangle MLT and triangle MNT are equal, I think it says equal. I'm zoomed out a little bit. What is used to prove angle 1 is equal to angle 2? You remember congruent parts of congruent triangles are congruent, or you can try to use definitions of all those different things. Figure out which one works best for that. Number 27. Let's see here. What are the congruent triangles in the diagram? Remember, order matters. So make sure that your letters are in order before you say that things are congruent. So for instance, A is surrounded by one line with one hash mark and one line with two hash marks. So it needs to match up with the other point on the other triangle that also has one line with one hash mark and one line with two hash marks on either side. 28, triangle KLM is an isosceles triangle, and angle 1 is congruent to angle 2. Name the postulate that could be used to prove LKP is congruent to LMN. And you got to look through your list of postulates, okay? You know certain facts about isosceles triangles. You know certain facts about their angles, the measures of the legs and the interior angles. So use that to your advantage. Number 29, given A is between Y and Z, and YA is equal to 14x, AZ is equal to 10x, YZ is equal to 12x plus 48. Draw it out, label your lengths, and then use algebra to solve. Very, very, very easy. So once you draw it out, you'll definitely understand. 30, complete the proof. So basically we're going to fill in 5 and 6. We need to state what property is true when we can substitute certain things or flip certain things around, or any number of those things. So make sure you review your list of properties. I know Daniel loves proofs. So Daniel, please make sure you review your list of properties and go back through these and see if that helps you out. Number 31. Name the longest side. Longest side is always opposite the longest angle, so I hope that one helps you out. Find number 32, find the possible values for the measure of angle 1. Don't forget, exterior angles must equal 180 minus the interior angle. Remember that 62 degrees is there to help you figure out what could possibly be that. And also, that exterior angle must equal the other two angles. So not the interior angle, but the other two angles. So what I mean by that is the diagram is something like this, with that as our exterior angle. Remember that this angle has to be equal to these two angles, because these three equal 180 and these two equal 180. So this one must be the same as these two combined. All right. And number 33, YW is an altitude. And then, let's see, the instructions say refer to the figure to determine which is true about the given information. So YW is an altitude. You have to figure out which one is true. Please make sure you're reading your definitions of altitudes, medians, and all that good stuff. Plus it says, is it an isosceles triangle? It does not say. So make sure you're paying attention to that. Can't believe anything. Can't believe the picture, right? Can't believe it to tell that it's true unless you can prove it. 34 is the same thing. It's a median this time. What's the definition of an altitude? What's the definition of a median? Does an altitude have to intersect at 90 degrees? Does a median have to intersect at 90 degrees? That's two very important pieces of information right there to help you out. And number 35, which of the following sets of numbers can be the lengths of the side of a triangle? Remember, you can't have two lengths that are greater, two lengths that are greater than the opposite length, right? Or two lengths that are less than or equal to the opposite. That's right. Two lengths that are less than or equal to opposite lengths. So make sure that each piece can add up to more than or equal. Let's see. Yeah, each piece can add, two pieces can add up to the third piece. The two smaller pieces need to add up to more than the third piece, right? And then subtraction also has to work the other way around. Number 36, what is the relationship between the measures of angle 1 and angle 2? That one you're going to have to use a little bit of math to solve. Let's see. Finding the interior measure of that interior line should help you out. Let's see here. Okay, number 37, list the angles of angle GHI in order from least to greatest. Angles are always opposite the corresponding lengths, so the largest angle will be opposite the largest length. The smallest angle will be opposite the smallest length. Number 38, write an inequality to compare. Let's see, write an inequality to compare EF and GH. EF and GH. All right, so write an inequality to compare those two. We have a little bit of a reference point with GF and HE. Both of those are 6, and then we have interior angles. So once again, larger lengths are opposite larger angles, all that good stuff. And we know that HF is going to be the same for both of them. Okay, 39, a convex pentagon has interior angles with measures blah. Find X. So draw a picture. It's a pentagon, and so it has 5 interior angles. All right. 40, the measure of two sides of a triangle are 14 feet and 29 feet. If the measure of the third side is X meters, find the range. So you have to assume that that piece is going to be the smallest value all the way to the largest value. So solve it as if X were the smallest value, and solve it as if X were the largest value, and it must be everything in between those 2 points. Let's see, 41. Find the sum of the measures of the exterior angles of a convex 21 gon. We had a formula for that, so make sure you check your notes for exterior angles of shapes. Find the measure, so same thing for 42, same thing for 43. We had all those formulas that are definitely in your notes. For isosceles trapezoids 44, MNOP, find the measure of angle MNQ, about to sneeze. If it's an isosceles trapezoid, which it says it is, then the two base angles must be the same. That'll help you out. Number 45, for parallelogram ABCD, find the measure of angle 1. Opposite interior angles come into your favor in this one. Also understand that triangles are 180 degrees. Vertical angles are opposite, and then that center is going to equal to 360 degrees. So use all that stuff to your advantage, and it shouldn't take you very long. 46 for rhombus ABCD, if the measure of angle 1 is equal to 6x squared minus 6, find x. So what's true about a rhombus, those intersecting diagonals have to intersect at what angle? Make sure you check that out. That's a very specific angle. Number 47, to prove that the diagonals of a square bisect each other, you would position and label a square in the coordinate plane and then find which of the following. Well, that one, just draw it out. You'll definitely be able to help yourself on that one. Once you draw it, you'll understand what they're looking for. Number 48, on your own notebook paper, write a 2-column proof. Ooh, that's fun. 49 is 2-column proof, and 50 is 2-column proof. Like I've told y'all from the get-go, there are multiple ways to write proofs. There is one example of each of these in your key. I hope that helps you out. If you have any questions, please make sure you write them in the comment section of Google Classroom, again, not of this video on YouTube. But check daily for YouTube videos. Hopefully, if I can stop having technical issues, I can get all this stuff done by noon every day. That way you have plenty of time to work on it. And you have a great day.